On this problem, we just do a few cross products. So the cross product of two vector v and w. First, we're going to write ijk, and then the first vectors, the components, and then the components for the second vectors. And then this is the two bar is for determinant, 3 by 3 determinant. To do that, first we cover ijk, and then for the first column corresponding to the I, we cover the row and the column that containing I, and so we got left is a 2 by 2 determinant. Next, we cover the row and the column of J, and we have this 2 by 2 determinant, but the sign is going to alternate from plus to minus. And then we cover K, and we have 2 by 2 determinant, and the sign will be plus, so plus, minus, and plus. Right, so that is the cross product. Of course, the 2 by 2 determinant, to do that, we just take V2 W3 minus V3 W2, and that is the 2 by 2 determinant. Multiply, subtract the first product, subtract the other product, and then that will be continued. Right, we look at the first example here. So first, we can rewrite this as v, vector v is that 3 component 2, negative 1 and 3, and vector w 3 component 3, negative 2, and of course I forgot the 0 for there's no I, 3 for j, negative 2 for k. So that's what we have. Now v cross w, right, so 3 component 2, negative 1 and 3, cross with 0, 3 and negative 2. Right, so this will be a 3 by 3 determinant I, j and k on the first row. The second row is the first vector, and the third row is the second vector. Right, now with corresponding to I, we're going to cover the I component, and we have negative 1 and 3 and negative 2. That for the I component, and then minus for the J component. We're going to have that 2 and 0, sorry, 2 and 3, 0 and negative 2. That for J, and for K, 2, negative 1, 0 and 3 for K. Right, now 2 by 2 determinant, we're going to take the product of this minus the product of those two. So negative 1 times negative 2 is 2, minus 9. That will be for I. For J, we have 2 times negative 2. That's going to be negative 4, minus 3 times 0, that is 0. And then next, 2 times 3 is 6, minus 0 is K component. And we're going to have negative 7 I plus 4J plus 6K. And that is the cross product of V cross W. Now we do the opposite direction, W cross V. I'm going to change the color. Now we do W cross V. W, the vector is going to be 0, 3, and negative 2. Cross with 2, negative 1, and 3. Right? So this is going to be equal to JK on the first row, and then the first vector, second vector, right? Cover I, J, and K. Cover I, we have this 3, negative 2, negative 1, and 3 for I. For J, it's a minus 0, negative 2, 2, and 3 for J direction. And for K, 0 and 3, 2, and negative 1 in the K direction. Right? So that gives us 9 minus 2, so it will be 7i. 0 minus 4 minus negative 4, it's going to be positive 4, but with another minus, so we go back minus 4j. And 0 minus 6k. Right. So that is the cross product of W and V. W cross V give us this. Now that's the answer, but if we compare this and this, what we see is that the cross product of V cross W has the opposite direction as the cross product of W and V. So if we interchange the vectors, we're going to have opposite direction. So that is, we have V cross W equal to opposite of W cross V. In general, that's what we have, and the result here confirm that. Right. Next we have the cross product of V and itself. The vector V is 2, negative 1, and 3. 2, negative 1, and 3. Right. So this is going to be a 3 by 3 determinant. The first vector and the second vector are the same. So first, again, we do the same thing, cover I, J, and then K. The J is going to take the negative coefficient, so negative 1 and 3, opposite as the 2 by 2 determinant. I minus 2, 3, 2, 3 for J, and for K, 2, negative 1, 2, and negative 1 for K. And here we see that negative 3 minus negative 3, so we're going to have 0i, 0j, and 0k. Or we can write like this, or just that is the move phase 0, or this is the 0 vector. So in general, any vector cross with itself is equal to 0 vector.